Your container is gone. The logs just stop, mid-sentence. No stack trace, no error, no goodbye. All you get is a number, 137, and somebody on your team will say it ran out of memory. Sometimes they are right, often they are not. And if you stop at that answer, you will spend the afternoon raising a memory limit that was never the problem. So let's take that number apart. 137 is not an error code somebody chose. It is arithmetic. On Linux, when a process is killed by a fatal signal, the shell reports its exit status as 128 plus the signal number. Signal 9 is SIGKILL. 128 plus 9 is 137. That is the whole story that number tells you. Something outside your process sent SIGKILL. It names the weapon. It does not name the shooter, which explains the silence. SIGKILL is one of only two signals a process cannot catch, cannot block, and cannot ignore. There is no handler. Your shutdown hook does not run. Your buffered log lines are never flushed. The kernel simply stops scheduling you and reclaims your pages. So the last line in your logs is not the last thing that happened. It is just the last thing that happened to already be written to disk. People read that final line like a clue. Usually, it is a coincidence. Now, the most common sender, the kernel's out-of-memory killer. And here is the part that surprises people. This is not a Kubernetes feature. It is a Linux kernel feature. Your container's memory ceiling is enforced by the kernel's control group memory controller. Cross it, and the kernel picks a process inside that group and kills it, immediately, with no grace period and no warning. Kubernetes does not do the killing. Kubernetes reads the exit code afterwards and writes a label on the corpse. The kernel is the enforcer. The orchestrator is just the coroner. But SIGKILL has other senders, and this is where the memory assumption costs you. Picture a liveness probe that starts failing. The Kubernetes decides your container is unhealthy and asks it to stop, politely, with SIGTERM. Your app ignores it, maybe because it is stuck on the very thing that made the probe fail. The grace period runs out, and then the Kubernetes escalates to SIGKILL. Exit code? 137. Identical. Same number when a pod is deleted and the app will not shut down in time. Same number when a node is drained. In every one of those cases, memory was never involved, and raising the memory limit changes nothing at all. So how do you tell them apart? You stop reading the exit code and you go read the pod's last state. Describe the pod and look at the terminated block. If the kernel's out-of-memory killer fired, the reason field says killed in plain text. That is the fingerprint. No killed, just an error with 137 and a failing probe in the events list. That is the escalation path, not a memory problem. Pause this and go look at a real one in your own cluster. Find something that exited 137 and check whether the reason field actually says killed. That single field decides which afternoon you were about to have. Two things worth doing today. First, handle SIGTERM properly in your app and actually finish shutting down inside the grace period. Every SIGKILL you avoid is a container that gets to flush its logs and tell you why it left. Second, for anything you care about, set the memory request equal to the memory limit. That takes your workload out of the overcommitted bucket, so the kernel is not choosing between you and a noisy neighbor. So the number was never the diagnosis. 137 means somebody sent SIGKILL, and your job is to work out who. The kernel, because you crossed a C group ceiling. Or the Kubernetes, because you would not stop when it asked nicely. Next time you see those logs cut off mid-sentence, do not reach for the memory limit. Reach for the last state and find out who pulled the trigger. That is what 137 actually says. Follow compile for what's under the hood.